Assalamualaikum warahmatullahi wabarakatuh. My name is Luman Hakimi Roslan, and today I would like to solve a question from our assignment. I was assigned to solve question 1A, which is evaluate the following integral using integration by parts. Okay, as you can see here, this is my assigned question. For our question, we have to remember the formula, which is integrate u dv equal to uv minus integrate v du. So after we write down the equation, we have to know which one is u, which one is v. So let's determine them. Here, as you can see, ln t is labeled as u because in Layet, ln is defined as L, logarithm. So we have to prioritize ln t as u, as our u. So the rest are the dv, which is t4 dt. For second step, we have to differentiate u, which is going to be 1 over t dt, and then we integrate dv, becoming t power of 5 over 5. So for the step 3, we write down back the equation, and then follow the formula. U is ln t multiply v, which is t5 over 5, minus integrate v du, which is t5 over 5 and 1 over t dt. And then let's solve them one by one. First, we have to simplify the integration here. T5 over 5 multiplied by 1 over t, we can get t4 over 5 and t4 over 5 dt. And then we put out the 1 over 5 from the integration, becoming integrate t4 dt. And then we have to integrate the t4 dt, becoming t5 over 5. And then the equation is gonna be more simpler, and then we can solve them. Ln t multiply t5 over 5 minus 1 over 5 multiply t5 over 5. Then we got the answer ln t multiply t5 over 5 minus t5 over 25. So this is our final answer, and please don't forget to put plus c, because this integrate doesn't have limit, so we have to put plus c. And then that's it. This is the final answer of the question. Thank you for watching.
Hi and Assalamualaikum. My name is Amiruzzam bin Zuraimim. My metric number is 2022-800-408, and I will explain question 1 number 2, which is integration by part. So the question is integrate with limit pi over 3 and 0, integrate sin x times ln cos x dx. So we need to substitute first. I will take cos x and then the u become du over dx, and cos x is negative sine x, and this become the dx equal to negative 1 over sine x du. So from the question, sin x ln cos x, so from the question, sin x and then the ln cos x, the cos x become u, and the dx become negative 1 over sine x du. So here we can cancel out sine x and remove this negative outside, and then the question will be like this: negative integrate pi over 3 and 0 ln u du. So here we can continue the integration by part. So the integration by part formula is this one: u dv equal uv minus integrate v du. But we can see here the equation using u alphabet, and I will change the u alphabet from the formula become z. V dz. To make then we continue the integration by part. So we can see here we had ln u and du. So I will take ln u as z, and dv is du. Then go to the next step. Z will become dz over du. So ln u will be 1 over u, and dv equal to du, then v equal to u. Here dz equal to 1 over u du. So we continue with the formula, which is this one. So negative integrate pi over 3 limit and 0 ln u du equal z and v. V is u and z is ln u, minus, this one minus, and integrate v and dz. So v is u and dz is 1 over u du. 1 over u du. So we can see here, we can cancel out u, and then this will be u ln u minus, and integrate 1 du, this will be u. So before we continue, we need to remember that our equation have this negative. So from this, we need to change the positive and negative here and here. So this will be I will put this u at the front, u, then minus, because this is positive, become minus, then u ln u. So this is the next step. Then we continue. From this, the u, we need to put the cos x into u. So u is cos x, and u cos x minus cos x ln cos x. We not plus c because we have this limit. Then we continue the limit. So we have pi over 3 x equal to pi over 3 and 0, x equal to 0. And then we put the limit inside the x. So here we continue. Cos and ln cos minus with also cos ln cos and the first big bracket we put the x over 3 in the x, and the second big bracket we put 0. And then we continue calculate this. from the calculator, we need to change the radian first. So cos pi over 3 equal to 1 over 2. And minus cos pi over 3, 1 over 2 again, ln 1 over 2 bracket minus cos 0 equal to 1 minus cos 0 1 and then ln cos 0 1. So here we simplify. 1 over 2 minus 1 over 2 ln 1 over 2, then minus this inside 1 and then minus ln 1. So ln 1 equal to 0. So 0 times 1 is 0. And then this will be 1 over 2 minus 1 over 2 ln 1 over 2 minus 1. So the final answer is the value negative 0.15343. That's it. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syafiq bin Muhammad Juraimi. My student ID is 2022844112. And for this Mat project, I have been assigned to do the question number 2. So evaluate this equation. So since the given is for the trigonometric substitution, so we must use the 2 sin theta. And when we look for this expression, we know that this is the expression for the sine expression. So from this expression, we can identify the a value and x value. So I identify a value is a 2 and x value is 1. So and then we know that b over a sine theta is equal to x, and then what we get is 2 over a sine theta is equal to x. It is the same as this one. So we just let x, and then after we let x is, and then what we have to do is we differentiate the dx over d theta to get the dx over d theta. So since differentiate, we get cos. So multiply the 2, then we get 2 cos theta. After that, I move the d theta into the right side and left only dx on the left side, and I get dx equal to 2 cos theta d theta. After do all the substitution value, all the substitution value, what I do is I replace all the substitution value to the equation, to this equation. So I show you. I replace, so the equation is dx, so we replace dx with the 2 cos theta d theta. So I just replace it like this, and x as the 2 sin theta. I replace it this and this. After that I simplify this equation such as I settle this calculation, which is 2 sin theta square, and then we get 4 sin square theta. Same into this equation, we get 4 sin square theta. The next step for this equation, equation is what we must do is we factorize this expression, the power expression, and then we get square root 4 times 1 minus sin square theta. In the previous chapter, we know that this we can use this as an identity formula, which is cos square theta plus sin square theta equal to 1. And then we move the sin square theta into the right side, and then we get 1 minus sin square theta equal to cos square theta. Then we can replace cos square theta into this expression. After that I replace it into this equation, then we will get this equation. And then the next step is we just simplify the calculation in this equation. So I just simplify square root 4 cos square theta, we get 2 cos theta, and then we wrote it. And if we see, there is same expression, which is 2 cos theta at the denominator and 2 cos theta at the numerator. So we can cancel out this expression, and then we wrote it back. We get d theta over 4 sin square theta. To make it easy for we to integrate this equation, I put out the 1 over 4 like this, and then we know that 1 over sin theta is equal to the cosec theta, and then so that means 1 over sin square theta equal to the cosec square theta. So I replace the sin square theta with the 1 over sin square theta with the cosec square theta. Then we will get this, and then we just integrate it. Cosec square theta integrate, we get negative cot plus c, and then we still have 1 over 4. We must multiply it with the negative cot, and then we get negative 1 over 4 cot plus c. Okay, to get the theta, to get the value of theta of this equation, what we must do is since the given is x is equal to the 2 sin theta, we can use the trigonometric and theorem Pythagoras. So we know that since sin equal to the opposite over hypotenuse, so we can just move it, then we get since theta is equal to the x over 2. So that means x is equal to the opposite. So when we draw the triangle, we can use draw x at the opposite and H 2 at the hypotenuse, like this. After that, we can identify the A adjacent, which is square root 4 minus x squared, like this. And then, since the equation we get is cot negative 1 over cot theta plus c, that means, and we know that cot theta is equal to the 1 over tan theta. And then, the formula for tan theta is opposite over adjacent. So we already have the value of opposite, which is x, and value of adjacent, which is square root 4 minus x squared. So we just wrote it back, and then we just flip it back, and then we got the value of cot theta. After get the value of cot theta, we wrote back the equation, which is negative 1 over 4 times the cot value that we get in the triangle, which is square root 4 minus x squared over x plus c. And then we get the final answer is square root 4 minus x squared over 4x plus c. This is the final negative. This is the final answer for the question number 2. Thank you. Question 2a. Complete the square for this equation. Okay. To solve this problem, we must use the formula of completing the square. This is the formula of completing the square. First, we must rearrange the equation into this. So that's easy for we to identify the A, B, and C value. So, and put out the A value, B value, and C value. So after that, I put out the A value, which is negative 1, and B value, which is negative 2, and C value negative 3. C value 3, and then I insert it in the formula. After insert it in the formula, calculate it by using the calculator, and then we get this equation, and then solve it, and then we get the final answer, which is negative x plus 1 square and plus 4. We also can rearrange it into this. So this is the final answer for question 2a. For the equation 2b, from this equation, we must solve it using a substitution trigonometry, and the trigonometric substitution is given, which is 2 sin theta. So in the previous question, and we know that 2 minus 2x minus x squared is equal to the 4 minus x plus 1 square from this equation. So we can just substitute it into this equation. Then we will get this equation. After that, when we see this equation, we know that this is the expression of sin. And so I let a bx, which is x plus 1, into the 2 sin theta. The 2 sin theta is given in the equation. And then after that, after I let it, I differentiate it into the term of theta, which is 2 sin theta differentiate, we will get 2 cos theta. And then in term of the x, we want only the x because we want to substitute it into this equation. Then we just rearrange it, and then we will get 2 cos theta d theta. After solve all the substitution, insert all the substitution into the equation in the previous. So x is equal to the 2 sin theta minus 1. So we put it in, so we substitute, then we will get into like this. And dx is equal to the 2 cos theta d theta. Put it inside, and we know that x plus 1 is equal to the 2 sin theta, so we substitute it into this equation. After all the substitution has been put into the equation, then simplify it, then we will get like this. After this step, what we must do is factorize, and then we will get 2 cos theta, because we factorize the 2, and we will get 2 cos theta multiply 2 sin theta minus 1. And for the below, I factorize the 4, and then we will get 4 multiply 1 minus sin 2 theta. In the trigonometric substitution, we learn that the identity of 1 minus sin square theta, we can find it by using the identity. The identity is cos square theta plus sin 2 theta is equal to the 1, and we can find the 1 minus sin 2 theta, which is cos 2 theta. After that, when we get the cos 2 theta, we substitute it into this equation, and then we will get like this. After substitute the cos 2 square theta, what we must do is I solve the equation for this expression, then what we get is 2 cos theta, and then we can cancel out this 2 cos theta, because this is the same as at the up expression, so we just cancel out. After that, the only left is 2 sin theta minus d theta, then we can just integrate it. So we can just integrate it. We know that sin theta integrate will become minus cos theta. So multiply 2, then we will get 2 negative 2 cos theta. So, and then negative d theta integrate, we will get minus theta. Since there is no limit given, so we put plus c. After get this equation, what we must do is find the theta. So the theta is from the given is 2 sin theta is equal to the x plus 1. This, and then we know that sin theta is equal to the x plus 1 over 2. Also, we know that the formula of trigonometry is sin theta is equal to the opposite over hypotenuse. So the theta is sin inverse x plus 1 over 2. So after that, what we must do is make a triangle like this, and then find since the equation have a cos, using a cos formula for the trigonometry, which is adjacent over hypotenuse, then we will get this expression. After that, so we can write up the final answer, which is negative 2 multiply cos theta, which is this equation. Minus theta. We know that the theta is sin inverse x plus 1 over 2 plus c. And then just simplify the equation. We can just cancel out this and we get negative. This 2 square is equal to the 4. So we can just write out x plus 1 equal to minus x plus 1 plus c. Okay, this is the final answer for the question 2b.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif bin Abdul Wahab, and here I will present you how to solve question number 3 mini project. Okay, the question is evaluate the following integrals. Integrate x cubed plus x squared plus 1 over x minus 1 x squared plus x plus 1 x squared plus 1 cubic. Okay, for this question, we use partial fraction, which is we divided by 6 part, which is a over x plus b over x minus 1 plus cx plus d over x squared plus x plus 1 plus ex plus f over x squared minus 1 plus gx plus h over x squared plus 1 squared plus ix plus j over x squared plus 1 cube. And then we make sure the denominator the same. So we multiply this denominator with this part, and then we got this equation. Okay, for the next step, we assume that x equal to 0. So we replace x with 0 in this equation, and then we got a equal to negative 1, and the same step we use for x equal to 1. We replace x to 1 for this equation, and then we got b equal to 1 over 8. After that, we expand this six equation. For the equation 1, when we expand, we got negative x the power of 9 minus 3x the power of 7 plus x the power of 6 minus 3x the power of 5 plus 3x the power of 4 minus x cubed plus 3x squared plus 1. And for the number 2, same, we expand them. We got 1 over 8 x the power of 9 plus 1 over 2 x the power of 7 plus 3 over 4 x the power of 5 plus 1 over 2 x the power of 3 plus 1 over 8 x the power of 8 plus 3 over 8 x the power of 6 and plus 3 over 8 x the power of 4 plus 1 over 8 x squared plus 1 over 8 x, and same with for others like this. Okay, for the next step, we factorize this equation to following the power, which is x the power of 9 until
at the power of 1. So from that we got the equation. So from this equation we use simultaneous equation to get c equal to -1, and the second one e equal to 15/8, and the third one I equal to -1/2. For the fourth we get d equal to -1. For the fifth h we got 3/4, and for the f we got -1/8. For the seventh we got j equal to 1/2, and for the last one we get g equal to 3/4. Okay, after that we replace the alphabet here to the answer we get from here. Okay, and then we get this integration. So from this one we separate them into integrate -1/8 dx plus integrate 1/8 x minus 1 dx plus integrate x plus 1/x square plus x plus 1 dx plus integrate 15x minus 1/8 x square plus 1 plus integrate 3x plus 3/4 x square plus 1 square minus integrate x minus 1/2 x square plus 1 cubic dx. Okay, for the first simplest one, we got -1/x integrate, we got negative ln x plus c. Okay, for the second one we use substitution. We substitute x minus 1 into u, so we got the last answer is 1/8 ln x minus 1 plus c. Okay, for the number 3, the start of the tricky equation. So from this we use factorize to factor x plus 1 into 1/2 to x plus 1 plus 1/2. So after that we separate them into two parts, which is one here, 1/2 integrate 2x plus 1 over x square plus x plus 1 dx plus 1/2 integrate 1 over x square plus x plus 1 dx. Okay, for this equation we use substitution, and then from this equation we use inverse trigonometric function. For the answer we get 1/2 ln x square plus x plus 1 plus 1 over square root 3 tangent inverse 2x plus 1 over square root 3 plus c. Okay, for the number 4, we use the same method, which is use substitution and tangent inverse function. Same with the number 5. For the number 5, first of all we use substitution, and then for this one we use reduction formula here, and then after that from reduction formula we use tangent inverse back to get the answer -3/8 x square plus 1 plus 3x/8 x square plus 1 plus 3/8 tangent inverse x. Same with this method, we use reduction formula here. Okay, for the first one we use substitution, and then for the second one we use reduction formula, and after the reduction formula we use this trigonometric function, which is tan inverse trigonometric function, and then the answer we got -1/8 x square plus 1 square minus 3x/16 x square plus 1 minus 3/16 tangent inverse x minus x over 8x squared plus 1 squared. So the final answer for this question is negative ln x minus 1 over 8 ln x minus 1 minus 1 over 2 ln x squared plus x plus 1 minus minus 1 over square root 3 tangent inverse 2x plus 1 over square root 3 plus 15 over 16 ln x squared plus 1 plus 7 over 16 tangent inverse x minus 3 over 8x squared plus 1 plus 9x over 16x squared plus 1 plus 1 over 8x squared plus 1 squared plus 8x over 8x squared plus 1 squared plus c. Okay, that's all for me. Thank you.
Hi, Assalamualaikum. My name is Muhammad Haziq Memiswan. My student ID is 2022876254 and I'm from the MK3M2A. For the Mat project, I've been assigned to do the question 4. So the question 4 is, the rational number 22/7 has been used as an approximation to the number 5 since the time of Archimedes. Show that x to the power of 4 times 1 minus x to the power of 4 over 1 plus x to the power of 2 dx with the limit of 1 and 0 equal to 22/7 minus 5. For this question, firstly, we must expand the numerator to convert the equation into a rational function. Then we get the fraction like this. From the fraction, we can see that the functions are in improper fraction because the degree of the numerator are bigger than the degree of the denominator. In this case, we use the long division of polynomials to write the ratio as a polynomial with a remainder. The formula for long division is like this, where the Q is quotient, R is remainder, D is divisor. So, to do the long division, the first step is to write the denominator beside the division symbol, where the indices are in an ascending order. Then write the numerator outside the division symbol. Use a 0 to fill in the missing term. Then divide the first term inside the division symbol with the first term at the outside of the division symbol. Then we put x to the power of 6 at here because it has the same degree of the inside the division symbol. Then we multiply the x to the power of 6 with the all terms at the outside of the division symbol. Then we put subtract and we put bracket to avoid error. Then we subtract the all terms. After that, we bring down all the remaining terms. Then we get the function like this. So we can see that this is the remainder, this is the quotient, and this is the divisor. So as we can see that the degree of the remainder are higher than the degree of the divisor. So we continue to do the division until the degree of the remainder less than or equal to the degree of the divisor. So using the same method, we continue to do the long division. Lastly, we get the answer for the long division like this. We can start to transfer all the remainder, quotient, and numerator and divisor into the formula of long division, which is this. So from these functions, we can start to integrate because all the terms are in polynomial functions and the fractions are in proper fraction. To integrate, the first step we can do is first we can express into the sum of partial fraction. For this term, we can integrate as usual, which is the degree of x plus 1 and x will be divided with degree of x plus 1. Then for these functions, we can do the integration of inverse trigonometric function. We use the formula for integration of tan inverse where s square is 1 and u square is s2. And the last step is we substitute the limit x equal to 1 into the x and minus with the limit x equal to 0. After we substitute, we calculate it by using calculator and we get the answer is like this. So our method successfully to show that x to the power of 4 times 1 minus x to the power of 4 over 1 plus x square dx with the limit of 1 and 0 equal to 22 over 7 minus 5. So that's all from me. Thank you.